Next question. A helicopter flies along the sides of a square field of side length 100 kilometers. Okay, we have a square 100 kilometer, this is 100 and this is 100. Okay, the first side is covered at a speed of 100 kilometers per hour, and for each subsequent side the speed increases by 100 kmph. All right, so this one, the helicopter is covering at 100 kilometer per hour, this one at 200 kilometer per hour, this one at 300 kilometer per hour, and this one at 400 kilometer per hour, right? So that's what it is. The average speed of the helicopter. Looks like an easy question, just some calculation required. So what is average speed? Total distance by total time, right? What's the total distance? 100, 100, 100, 100, 400 by total time. What is total time? 100 by 100 plus 100 by 200 plus 100 by 300. Now we don't have to really write all of this. We could have just simply written 1 by 2, 1 by 3, 1 by 4 also, right? So this becomes 400 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, right? Take LCM. 400 by 2, 3, 4. LCM is 12. 12 plus 6 plus 4 plus 3. So 400 into 12, 4800 divided by 10, 22, 25, right? So how much will this be? 5 5s are 5 9 60s are 5 192s are option 1, 192 kilometers per hour. That's the average speed. Next question. If the harmonic mean of the roots of this equation is 4, then the value of b is, first of all, what is harmonic mean of two numbers? Here we have roots, right? Let the roots of the equation be alpha comma beta. What is the harmonic mean of alpha comma beta? 2 alpha beta by alpha plus beta. This is equal to 4. All right. So 2 times, what is alpha beta? Alpha beta is product of the roots, which is c by a. Remember, this whole part is a, this part is b, and this whole part is c. Sum of the roots is minus b by a, product of the roots is c by a. So what is product of the roots alpha beta here? 8 plus 2 root 5 divided by 5 plus root 2. All right, and the denominator, what is sum of the roots? Alpha plus beta minus b by a, minus of minus b, b by 5 plus root 2, right? So 5 plus root 2, 5 plus root 2 cancels. What do we have? 2 into 8 plus 2 root 5 by b is equal to 4. Okay, 2 cancels here again. 4 plus root 5 is equal to, when I cross multiply, b. So b is equal to 4 plus root 5. Next question. A polynomial p of x leaves a remainder 2 when divided by x minus 1 and the remainder 1 when divided by x minus 2. Okay, before we read further, we have studied remainder theorem, right? What does it mean? When a polynomial p of x is divided by x minus a, the remainder is p of a or f of a, correct? So p of x when divided by x minus 1 leaves a remainder 2. What does it mean? X minus a, p of a. So p of 1 is equal to 2. Similarly, when divided by x minus 2, p of 2, remainder is 1. So p of 1 is 2 and p of 2 is equal to 1. Now, what is the remainder when p of x is divided by x minus 1 into x minus 2? All right. P of x is being divided by x minus 1 into x minus 2. Okay. So this is x square minus 3x plus 2, right? The remainder cannot have an x squared term, correct? It will have something less than that. So let's say a remainder of p of x when divided by x square minus 3x plus 2 is equal to something of the form, let's say ax plus b. I don't know whether ax will exist or not, b will exist or not, whether it is 0, I do not know, but I do know when p of x is divided by x square minus 3x plus 2, the remainder can't have the x square term, so the remainder can have only x term and a constant term, correct? So what do we do now? The remainder when p of x is divided by x minus 1 into x minus 2 is 1, right? Which means P of x is of the form x minus 1 into x minus 2 into some quotient plus ax plus b, right? P of x when divided by x minus 1 into x minus 2, this part is divisible, it leaves a remainder 0, that is the remainder, which means I can express my polynomial as P of x is x minus 1 into x minus 2 into some quotient plus some remainder, right? Now let's use these that we already know. P of 1 is 2, okay? P of 1 is equal to 2 is equal to, substitute 1 here, this whole thing becomes 0, substitute 1 here, 1 into a plus b equal to 2. Similarly, P of 2 is equal to 1 is equal to, substitute 2 in this equation, this whole part becomes 0, this becomes 2a plus b. A plus b is 2 and 2a plus b is 1. Subtract, what do I have? 2a plus b minus of a plus b, I'll get a is equal to minus 1, a is equal to minus 1, and what about b? B is equal to 3. So minus 1 into x plus 3. So 3 minus x is my remainder when P of x is divided by x minus 1 into x minus 2. So that would be option 1, 3 minus x. Next question. If cos alpha plus cos beta is 1, then the maximum value of sin alpha minus sin beta. Okay. So we have sin alpha, sin beta, cos alpha, cos beta. If we square them and add them, we can get 1. Then we'll worry about the remaining part. Let's square the first expression, first equation. Cos square alpha plus cos square beta plus 2 cos alpha cos beta is equal to 1. What about the second equation? Sin square alpha plus sin square beta minus 2 sin alpha sin beta is equal to, let's say this whole thing is equal to k, is equal to k square. I squared the first equation, both sides of the first equation, I squared both sides of the second equation. Now can we add the two equations? Because we can see this is a very useful property, sin square alpha plus cos square alpha is 1, we'll use it, right? This plus this is 1, sin square beta plus cos square beta is 1, plus 2 times cos alpha cos beta minus sin alpha sin beta is equal to 1 plus k square. What do we have? 1 plus 1, 2, 2 plus 2 times cos alpha plus beta. Cos alpha plus beta is cos alpha cos beta minus sin alpha sin beta is equal to 1 plus k square. Okay, bring 1 here. 1 plus 2 cos alpha plus beta is equal to k square. Now tell me, what is the question asking? Find the maximum value of k. The maximum value of k. What is k? Square root of 1 plus 2 cos alpha plus beta. What is this maximum value? When cos of alpha plus beta is maximum. When is cos alpha plus beta maximum? When the maximum value of cos of anything is 1. So 1 plus 2 into 1 plus 2 is 3. Square root of 3. This is the largest value that I can think of when alpha plus beta is 0 or when alpha plus beta is 90 or whatever, right? Sorry, not 90. When alpha plus beta is 0, we'll have cos 0 is equal to 1 and k will be root 3, right? Next, a rabbit is sitting at the base of a staircase which has 10 steps. Okay, it proceeds to the top of the staircase by climbing either 1 step at a time or 2 steps at a time. All right, the number of ways it can reach the top is. So it has a choice. It has to climb a total of 10 steps, right? But it can take 1 step at a time or 2 steps at a time, right? So 1 step and 2 steps. All right. So can it take all single steps, all 1 steps, right? Let's put it this way. X into 1 step plus y into 2 steps is equal to total steps is 10, right? Total number of single steps and total number of 2 steps. Can I take all single steps? Yes, absolutely. Why not? No 2 steps. Okay. Can I take 9 single steps? 9 single steps is 9 steps. There's only 1 step. You can't take half of 2 steps, right? So this can't be 9. This can be 8, 1, 2 steps, 2 steps and 8 single steps. 2 plus 8, 10, right? So now this is easy. 10, 8, 6, 4, 2, 0. On the contrary, what happens here? You take 6 single steps. You'll have to take 2, 3, 4, 5. So these are the 1, 2, 3, 4, 5, 6, 6 possible ways in which this rabbit can go from here to there. It can climb those 10 steps. Either all 10 are single steps, or 8 single steps, 1 2 steps, 1 double step, 6 single steps, 2 double steps, and so on till all 5 double steps, right? So in how many ways can the rabbit do this? All are 10 steps only. 1 step, 1 step, 1 step, 1 step, 1 step. All are 1 steps. It can do it in only one way. Similarly here, all 5 are 2 steps. It can do it in only one way, right? 2 jumps or 1 jump. Let's look at them. It's a rabbit, so it will jump. All right. Here, it will take 8 single jumps and a double jump, right? So total jumps is 9. Out of them, I just have to select 1, correct? Total jumps is 9. Out of them, I'll select 1. That will be a double jump. All the others will be 8 jumps. So 9C1, this would be 8 plus 1, 9C1, 9 ways. Okay, what about this? Total 8 jumps. Out of those, 2 will be 2 steps. All the other will be single jumps or single steps. So total 8 steps. Out of them, select 2, 8C2, right? 8C2 would be 8 into 7, 56 by 2, 28. The next one, what is this? 7. Similarly, 4 plus 3, 7C3. So 7C3 would be 7 into 6 into 5 divided by 3 factorial 6. So that would be 35, right? And what about this? 2 steps and 4 steps, total 6 steps. Out of those 6, select which 2 will be single steps. 6C2, 6 into 5, 30, 30 by 2, 15. What do we have here? So 9 plus 1, 10, 10, 38, 73, 74, and 14, 89. So we have option 4, 89. This is in how many ways it can reach the top by taking either 1 step or 2 steps at a time, right? Next one. In a group of 120 students, 80 students are from the science stream and the rest are from the commerce stream. All right. A group of 120, science stream is 80. Okay, and this is the commerce stream. The remaining are all from commerce stream, 40. All right. It is known that 70 support Mumbai Indians. Mumbai Indians supported by 70. All the other students support Chennai Super Kings. Okay, CSK. The remaining, there are 120, so the remaining 50 will support CSK. All right. The number of students, science students who are supporters of Mumbai Indians is, all right, check this. How many science students are there? 80. And how many of them would support Mumbai Indians? I don't know. It's possible out of 80, 70 support Mumbai Indians. All right, I don't know. But the question is asking exactly minimum, maximum, or something like that. Okay, between 15 and 25, I don't think so. I don't think so. Why? This is 120, this is 120. These 80 have to come here or here, right? Let's say first 50 of them go here, meaning out of those 80, 50 are Chennai Super King supporters, assuming for the minimum and maximum cases. If 50 are supporters of CSK, we still need 30 to come here, which means the number of people from science stream who are supporting Mumbai Indians is at least 30, option 2. Less than that is not even possible. Hey, 20, 20, 25, 15, 25 is not even possible. Assuming 50 go there, the other 30 have to come here. Correct? This is the assumption based on the question. So option 2, 30 or more. Next question. If a 3-digit number is chosen at random, all right, 3-digit number starts with 100, 101, so on, goes on till 999. So how many such numbers do we have? 999 minus 100, 899 plus 1. There are 900 such numbers. If a 3-digit number is selected at random, what is the probability that it is divisible neither by 3 nor by 4? All right. So how many of these numbers are divisible by 3 or 4 or both? Let's check that. Smallest number divisible by 3 is 102, 3 into 34. So until the largest such number is 999. So this is 3 into 34 to 3 into 333, right? So 3 into 34, 102 is the smallest number divisible by 3. 3 into 333, 999 is the largest number divisible by 3. How many such numbers? 34 to 333 both included. So 333 minus 34 plus 1, that's 300 such numbers. 300 numbers are divisible by 3. Okay, how many are divisible by 4? The smallest such number is 100. Largest such number is 999, but 999 is not divisible by 4. 996 is divisible by 4, correct? So this is a 4 into 25 all the way till 4 into 250 is 1000. So this will be 4 into 249, right? So how many such numbers are there? From 25 to 249, both included. 249 minus 25 plus 1, 250 minus 25, that would be 225 such numbers are divisible by 4. Some are divisible by 3, some are divisible by 4. But let's not forget, some numbers would be divisible by both 3 and 4. So we can't add 300 and 225 right away, because then there will be double counting. So let's find out how many numbers are both divisible by 3 and 4. Means they have to be divisible by 12, right? So 100, so until 999, which is the smallest number divisible by 12 here? 108. 108 is a 12 into 9, all the way till 960 is 80. Okay, 996, this will be 12 into 12 eights and 3s, right? So 12 nines to 12 83s. So how many of these numbers are divisible by 12? 83, 9 to 83 both included. 83 minus 9, 74 plus 1, 75. All right. Some are divisible by 3, some are divisible by 4, some are divisible by 12 here. So 300 plus 225 minus 75. How much is that? 450. Half of the numbers are divisible by 3 or 4. So if I want to pick numbers which are not divisible by 3 or 4, I have to pick the other half. Total 900 numbers. We got really lucky here. Half the numbers are divisible by 3 or 4. So the other half, 450 by 900, that should be option 2. 1 by 2. Next question. Okay, this is a set, comprehension based. A pharmaceutical company has tested 5 drugs on 3 different organisms. All right. These are drugs A, B, C, D, E. They're tested on organisms P, Q, and R. All right. If a drug works on the given organism or not. For example, drug A, all right, drug A works on organism R, while B works on Q and C works on R. All right. We have some additional information. Let's look at it. Each drug works on at least one organism, but not more than 2 organisms. All right. So drug A works on R. It could work on one more, but not more than 2 organisms. Means A can also work on P. If it works on P, it will not work on Q. If it works on Q, it will not work on P, and so on. Right? You will work on at least one, or A does not work on P or Q also. That's also fine. At least one has to be there. It has to work on, but it can't work on 3. So every drug will work on one organism or 2 organisms, one organism or 2 organisms, right? That's the conclusion. Next one. Each organism can be treated with at least 2 and at most 3 of these drugs. All right. So if you look at each organism can be treated with, if you look at P should be treated by at least 2 of these drugs, right? And at most 3 of these drugs. So P will be treated by 2 or 3. Q will be treated by 2 or 3. And R will be treated by 2 or 3. All right. On whichever organism A works, B also works. Okay, let's see. A works on R, which means B also works on R, right? On whichever organism A works, B also works. Similarly, on whichever organism C works, D also works. Okay, C works on Q, so D also works on Q. Okay, D and E do not work on the same organism. Okay, this is helpful actually. D and E will not work on the same organism. So if D works on Q, E will not work on Q. Okay, anything else we've missed? Each drug works on at least one, but not more than 2 organisms. Check, this is helpful. Check drug B. What did we agree on? That each drug will work on 1 organism or 2 organisms, but not more than 2, right? So B is already working on Q and R, not more than 2 means B cannot work on P. This is a cross, correct? Anything else? Each organism can be treated with at least 2 and at most 3 of these drugs. All right. So this is 2, I can have one more here. This is 2, I can have one more here. That's possible, right? On whichever organism A works, B also works. Similarly, on whichever organism C works, D also works. D and E do not work on the same organism. Now, come back to A. We know that on whichever organism A works, B also works. Now, can A work on P? No, A can't work on P because B cannot work on P. If A works on P, B has to work on P. But hey, B already reached the limit. B is already working on 2 organisms, which means A is also not working on P. Right? This is a useful result, correct? If A works on P, B should also work on P. But it's very clear that B cannot work on P. Now, look at organism Q. Each organism can be treated with at least 2 and at most 3. So check organism Q. It is already being treated by B and C and D, at most 3. That's done. That's the limit. So Q can't be treated by A, which means A can only treat R. B can only treat Q and R. Now what about, see, I got Q being treated by 3 drugs and R being treated by 2 drugs. But look at P, right? Each organism should be treated by at least 2. P should be treated by at least 2, which means in these 3 spaces I need 2 ticks at least. Now we also know D and D do not work on the same drug. So if D works here, E won't work. If E works here, D won't work, which means out of the 2 only one will work, which means I'll get 1 tick from here, which means C has to be a tick here, right? You following? Out of C, D, E, I need 2 ticks for organism P, correct? Now D and D can't both work for P because if D works, E will not work. So I'll get 1 tick from D or 1 tick from E. That's the only thing I know, correct? So 1 tick has to come from C. Now C, check this. Each drug works on at least 1 but not more than 2. C already works on 2 organisms, P and Q. So C cannot work on R, correct? So coming down here once again. Now check this. Check E. Whichever organism C works, D also works. If C works, D has to work. So if C is working here, D has to work. And since D works, E will not work. Now what? E. Every drug works on at least 1 organism. E got a cross here, so E has to get a tick here. And if E works, D cannot work, right? So this is what we have. Check P. 2 drugs entry P, no problem. Q, 3 drugs, no problem. R, 3 drugs, no problem. E1, D2, C2, B2 and A1. That's it. We've filled the table completely. Let's look at the questions. Okay, we've just tabulated the results here. Drug D works on, check, drug D works on P and Q. Alright. Organism R can be treated with A, B and E. Alright. A, B and E. Organism P can be treated with C and D. Only C and D. That's right, only 2 of them here. The organisms that can be treated with 3 of these 5 drugs is, okay, which organism can be treated with 3 of the 5 drugs? Q can be treated with 3, R can also be treated with 3. So that would be Q and R. Drug E works on only one of them, only R. So that concludes the quant section, at least the MCQ questions. We'll meet in another video to discuss all the subjective questions. Hope you've enjoyed the learning session.